Hello students, hope you all are enjoying the C++ video series. Our today's session is about operators and manipulators in C++. The objective of today's session is to know about the special operators in C++ and also manipulators in C++. Let's see the first one, that is operators in C++. Friends, as we all know, C++ is a superset of C language. That means all the operators available in C are also available in C++. In addition to those operators, C++ introduces some new operators like scope resolution operator, member dereferencing operator, memory management operator, and typecasting operator. Let's see the first one, scope resolution operator. As we all know, we can declare variables either globally or locally. That means a variable which is declared inside a function or block is called local variable for that function, and a variable which is declared outside the function or block is called global variable for that function. Friends, in C program, if we want to access a global version of a variable inside a block, then it is not possible. But in C++, the global version of a variable is accessed inside the function and block using a scope resolution operator. The syntax of scope resolution is scope resolution symbol with variable name. We can make this symbol by using 2 colon. The example is shown here, in which int m is equal to 10 is a global declaration of variable m, and int m is equal to 20 is a local declaration of a variable m, because this variable m equal to 20 is declared within the block of int main function. So if I am trying to display a value of m normally, then it will display 20. Now in next line I have written value of m with scope resolution operator. That means it will display the value of global version of variable m, that is 10. So the output will be 10, 20 and 10. So this is all about scope resolution operators. The next one is a member dereferencing operators. Friends, as we know that we can use pointers to point to normal variables and functions like integer, float, character, array, right, in C programs. Same way we can have pointers to class member functions and member variables. C++ provides 3 pointers to member operators to access the class member through pointer. Let's see them. The first one is a scope resolution symbol with asterisk symbol. This pointer is used to declare a pointer to the member class. That means the pointer variable will point to the member of a class. Then second one is a dot operator with asterisk. It is used to access a member using object and pointer of that class. And the third one is a arrow operator with asterisk symbol. It is used to access member using a pointer of the object and the pointer of the member. So this is all about member dereferencing operators. Now let's see the next one, memory management operators. In C programs, we are using calloc and malloc functions to allocate memory dynamically, that means at runtime. Similarly, we are using free function to free dynamically allocated memory in C programs. Same way in C++ we have unary operators new and delete. New operator is used to allocate memory dynamically, and delete operator is used to deallocate or free a memory at runtime. An object can be created by using new and destroyed by using delete operators. Let's see the first one, that is new operators. The new operator can be used to create objects of any type. So the syntax is name of a pointer variable is equal to new, that is the keyword, and then data type. Here we can have any data type like integer, float, character, or any user defined data type also. See the example, int star p is equal to new int. Here pointer variable p will be allocated memory dynamically, that is equal to the size of integer variable with using new operator. In the second line, float star q is equal to new float will allocate memory to the pointer q of size float variable. We can also initialize the memory with using new operator, that is syntax is pointer variable equal to new data type value. An example is int star p equal to new int 25. Here 25 is the value which is going to be initialized to the memory location which is pointed by pointer p. With using new operator we can initialize also our memory locations. Same way, new operator can also be used to create memory space for any data type like array, structure and classes also. So the syntax to allocate memory dynamically for array is pointer variable is equal to new and then data type into square bracket size. Here square brackets are used to show that the value written as a size will be the size of array. That means the number of elements of array. And the data type is any valid basic data type. New is a keyword which allocate memory space for pointer variable which is equal to the number of elements of particular data type. For example, int star p is equal to new int into bracket 10 will assign memory space for an array of 10 integers. Now let's see the delete operator. Delete operator is used to free the memory which is allocated by new operator. So whenever a data object is no longer needed, it is destroyed to release the memory space for use. For that we are using delete operator. Let's see the syntax. Delete and then pointer variable. Here pointer variable is a variable which is allocated memory dynamically using new variable. So whenever it is no longer needed, we can delete that memory space allocated to that pointer with using delete operator. For example, delete p will deallocate or free the memory space which is allocated to the pointer p which is previously declared with new operator. Same way, we can also free up the memory dynamically which is allocated to the array dynamically. Syntax for deleting dynamic array is delete into square bracket size of array and then pointer variable name. So here size specifies the number of elements in the array to be freed. For example, delete into square bracket, here bracket is empty and then p. So the empty bracket shows that we want to remove all the elements from the array. That means we want to free all the elements memory space from the memory using delete operator. Okay friends, our next special operator is a typecasting operator. So what is typecasting? Casting can be done to convert object of any scalar type to or from any other scalar type. It can be done in two ways, implicit typecasting and explicit typecasting. Let's see the first one, implicit typecasting. As we are doing in C programs, C++ also performs implicit typecasting. So what is implicit typecasting? Whenever data types are mixed in any arithmetic expression, C++ performs the conversions automatically. This process is known as implicit or automatic typecasting. That means, as we can see in example, m is equal to 5 plus 2.5. That means here one operand is in integer value and another operand is in floating point value. So the conversion of these output will be done automatically. That means 5 plus 2.5 is 7.5. Why? Because floating point numbers are having higher precedency over the integers. So automatically the implicit type conversion will be done. Now let's see the explicit typecasting. Same C++ also permits explicit type conversion of variable or expressions using the typecasting operator. The syntax is type name into bracket expression, and the example is float x is equal to 3.1 int I and then I is equal to int x. We can write either data type in brackets or expression in brackets. Any one of them can be written in a brackets. So here in our example, x is having value 3.1, that is floating point value, and integer is declared as, I is declared as integer. That means if I want to assign value x to I, then it is not possible because both data type are different. But implicit typecasting is not done automatically, so we are doing explicit typecasting with using explicit typecasting operator. So here we have written int into bracket and then we have written the x, variable x. So the value of I will be 3 because explicit typecasting remove the part of a floating point number after decimal point. Okay friend, now let's see the next topic, that is manipulators. So what are the manipulators? Manipulators are the special operators that are used for formatting the output of our program. So there are two mostly used manipulators. First one is ENDL and second one is a SETW. ENDL is a manipulator which is working similarly to the /n, that is line feed character in C programs, and SETW is working similar to the formatting the outputs. So SETW stands for set width. Let's see the first one, ENDL. The ENDL manipulator is used in the output statement when we want to insert a line feed, that means a new line. It has the same effect as using a new line characters in a C programs. Friends, /n new line character is also valid in C++ programs. Let's see the example. Here 3 variables are declared with 3 different values, and cout a equal to and then at the end ENDL manipulator. Same way value of b and value of c. Here 3 instructions are written. Each and every line is having ENDL as a new line character. So what happens in output? All these 3 values will be displayed in separate lines. Same way SETW is there. SETW manipulator is used to format the output. When we want to use the SETW manipulator, the output is formatted in a write justified. So this is the by default method of SETW. Before using SETW manipulator, we have to include header file, that is IO manipulator, input output manipulator. The syntax to use the SETW is SETW into bracket width. Here width is a number of character space that we want in our output. Let's see the example. See friends, we have taken the same example as that of ENDL. We have just added SETW manipulator before displaying our variable. So here value of A will be displayed in the span of 4 characters as we have specified SETW with size 4. Same way for variable B and C. Now let's compare the output of ENDL and SETW. So friends, see, here first table is showing the output of ENDL manipulator in which each and every variable's values are displayed in 3 different lines. But what is the difference between ENDL and SETW? Here also output is displayed in 3 different lines because we used ENDL in both the programs. But what is the difference? As we are using SETW, the value of particular variable is displayed within the width specified with a SETW function and in a right justified manner. So as we have defined SETW with 4 spaces, the value of A, that is 15, will be displayed in right justified manner. So the previous 2 spaces will be remain blank. Same way it will work for variable B and variable C. So if we want our values to be displayed right justified, then we will use SETW. By default, all the values with SETW will be right justified. But if we want to display the value, all the values with left justified, then also it is possible with SETW. Thank you.